Solve these equations. First couple of ones to review. Starting to get a little bit harder though. There's more going on, so let's go through a couple of these. We have 3 to the x squared over 3 to the x quantity squared equals 27. First thing we want to do is get one base. So we can see on this left side we have a base of 3, and we can write 27 as 3 cubed. We can simplify, get rid of these parentheses. So we're going to have to make sure that you're really solid on these rules when we're doing this. And that is 3 to the x quantity squared would be multiply the exponent, so 3 to the 2x. And let me just erase this so I'm not mistaken as to what I'm writing. So now we can combine the left side into one. There's multiple ways, again, always to go about these. We have the same base, so we can subtract the exponents. Now remember what I want you to always do, always do, get one base on each side before you set the exponents equal to each other. You have to get one base and it has to be the same. So we have x squared minus 2x equals 3. And now we can solve that simple quadratic equation. Move the 3 to the other side, factor x minus 3 times x plus 1 equals 0. X equals 3 or negative 1. And if we plug in 3 or negative 1 into this equation, it will work. There's a lot going on in this one. We have 8, 16, and 32 as our bases, so we can write them all as a power of 2. So we have 2 cubed, and then we have, so it'd be 3 times the quantity x plus 1 over 2 to the 4x, and all of that is being raised to the 1/3 power equals 2 to the 5th. Now again, it's your choice on how you want to go about doing this. We have this 1/3 power here. Instead of trying to apply the 1/3 to the top and bottom exponents, what I would rather do is raise everything to a power of 3 to both sides. And that way we don't have to deal with fractions. So if I raise this to a power of 3, the 1/3 times the 3 makes that 1. And on the right side, we'll have 2 to the 15. So we can start simplifying over here. We have the same base, so we can subtract the exponent. So we'll have 2. And if you want, we can just multiply this 3 times x plus 1 out at one time. So 3x plus 3. And then we're going to be minusing 4x, which is the same as 2 to the negative x plus 3 equals 2 to the 15. Now we have one base on each side, so a negative x plus 3 equals 15. If we move the x to the right side to make it positive and subtract 15, we get x equals negative 12. All right, let's take a look at number 3. Number 3 is a little bit challenging one at first when you haven't seen that exact type of problem before. Before we do this, let's compare how would we go about factoring 5x to the 4th plus 2x cubed. We'd say, what is the greatest common factor? We can see here that it's x cubed goes into both x to the 4th and x cubed. Now, original way you would have done this is you would have said, I'm going to divide by x cubed, and then we would write x cubed times 5x plus 2. Now that was way back in Algebra 1. At this point, what we would typically do is pull out the x cubed and say x cubed times what gives me 5x to the 4th? It would be 5x plus x cubed times what gives me 2x cubed? It would be 2. When we look at this, actually let's stay on this for just one more second. If we have, how can we identify which one to pull out? We have x to the 4th and x cubed. X cubed is the smaller of the two. Now let's come back to this thing. When we look over here, we have x minus 1 to the 1/2 minus x times x minus 1 to the negative 1/2. We can see x minus 1 in both of those, and so we can factor that out. Now, for some, it might help, at least initially, although I wouldn't recommend it to do it too often. You could do something like this. Let a equal x minus 1. So we have a to the 1/2 minus x times a to the negative 1/2. You can see that we have this base of a, just like you could see up here that it's x minus 1. If I take this idea there, my smaller of the exponents here would be negative 1/2. So if I factor out a negative 1/2 and I divide each term by negative 1/2, I'll have a to the negative 1/2 times what? Well, we'd have 1/2 minus negative 1/2. So that'd be 1/2 plus 1/2, or a to the 1, minus the a to the negative 1/2 reduce out, and we're left with x. If we applied this same idea with the x minus 1, or we could just substitute back in at this point, a is x minus 1 minus x. The x's go away, and we're just left with negative 1. So this is going to be negative 1 times x minus 1 to the negative 1/2, or just negative x minus 1 to the negative 1/2. So what if we, instead of approaching it that way, we realize that we have x minus 1, and we say our smaller exponent, so it's a negative 1/2, and we're going to say times what? Well, we want to get x minus 1 to the positive 1/2, so negative 1 plus what number will equal positive 1/2? Negative 1 plus 1. Minus, we're pulling out the x minus 1 to the negative 1/2, and there's an x left. And then we get our exact same thing. That's the same as this step. The inside part here of the brackets will simplify to negative 1, and we're left with negative of x minus 1 to the negative 1/2. Let's take a look at the next one. Next one's probably a little bit easier. We have x plus 1 to the 3/2 minus 4, x plus 1 to the 1/2. What are we going to pull out? Well, we see that we have an x plus 1, and the smaller of our exponents would be 1/2, just like we took the smaller of our exponents in this example. And x plus 1 to the 1/2 times what will give us x plus 1 to the 3/2? Well, we know the base is going to be the same, so 1/2 plus what number, because when the bases are the same, we're going to add the exponents. 1/2 plus what number gives us 3/2? 3/2 is 1 1/2, so 1/2 plus 1 minus 4. So we have x plus 1 to the 1/2 times x minus 3. And that problem's done. Number 5. Now we've seen a problem similar to this before, and let's see what we can do with it. What do you notice about this problem? We have x to the 4/3 and x to the 2/3. Number 1, we only have 3 terms. That's a key idea here. What could you do to x to the 2/3 to get x to the 4/3? Well, 2/3 times 2 is 4/3, or in other words, x to the 2/3 squared would give us to 4/3. So if we did something like let a equal x to the 2/3, this would be a squared minus 10a plus 9. Remember back in chapter 1 we had quadratic forms. This is another quadratic form. We also had it in one of the lessons in 5.1. At this point we can just factor it. A minus 1, a minus 9. So a equals 1 or a equals 9. Now we're not asked to solve for a, we're asked to solve for x. So x to the 2/3 equals 1, or x to the 2/3 equals 9. Now this next step is difficult because it's hard to see exactly what's going on here. You got to remember, what does this squared, this 2 mean? I just said it. It means squared. And the 3 means a cube root power. So we could do it in stages. And for this first one, I'll do it in stages. And then for the 9, I will just do it at one time. So let's say I raise everything to the 3rd power. So I get x cubed equals, or x squared equals 1. Now, how do I solve x squared equals 1? I'm going to take my square root, but I have my plus or minus, so x equals plus or minus 1. Now, if I did it all in one step, and I raised it to a power of 3/2, which is perfectly fine, I have to remember when I have that 3/2, that 1/2 power, that's really a square root. And so I must have my plus or minus, because really it's giving me that absolute value, and the absolute value gives me the plus or minus. So you get x equals plus or minus. Now, we could do this in any order. We could say 9 cubed and then square root, or we could say the square root of 9 and then cube it. I'd vote for the square root of 9, which is 3, and then cubed. So we get plus or minus 27. So there are 4 answers to this problem. It's not always easy to see that, but really you could think of this as just x to the 4th, and that could make sense that we would have 4 answers. Let's take a look at the next one. Again, a similar setup. We have 4 to the x. What do you do to 4 to the x? Get 4 to the 2x? Square it. So we can say let a equal 4 to the x. Now, is it required to do a substitution every single time? No. In fact, the goal will be eventually to try to do it without doing a substitution. But at least for now, that's a good way to start. So we have a squared minus 7a minus 8 equals 0. So we factor this. A minus 8, a plus 1. A equals 8, or a equals negative 1. Again, we're not solving for a, we're solving for x. So 4 to the x equals 8, and 4 to the x equals negative 1. Now this is a power of, our bases will be 2, so this will be 2 to the 2x equals 2 cubed. Now that our bases are same, our exponents are equal, so x equals 3/2. Now over here, do you notice anything about this one that's different? We have 4 to the x equals negative 1. What do you know about 4 to the x? Well, this is raise 4 to a power. If we raise it to a positive number, let's say 1 and bigger, 4 to the first, second, third, you get 4, 16, 64. They're getting bigger and bigger. They're not going to negative 1. What if we start getting smaller? 0 would be 1. 4 to the 1/2 would be 2. 4 to the 1/4 or 1/10. We're saying what number multiplied by itself for 4 to the 10th? What number multiplied by itself 10 times will give me 4? What's going to happen to all of those numbers when we go 4 to a power? Can we ever get a negative number out? No, we can't. There is no solution to this problem. And that's it for section 2.